Hi guys, welcome back to the show. Well, I'm not going to do a video on this, but after looking on the internet and finding out just how little information is on the internet, I decided to go ahead and start recording from where I am right now. This is a Tarheel screwdriver antenna, and it was already semi took apart when I started on it. So when I run into some more problems, I said, well, I might as well go ahead and start recording. Now I'm out here in the garage. It's a little hot. I've got the ceiling fan on, which isn't doing a whole lot, but so if you hear some creaking, that's from the ceiling fan. But we pull you in closer and show you just what we're working with here. Well, the first thing I noticed when I hooked power up to this motor, I put in 13.8 volts on the bench supply, and when I turned it on, it dropped down to 8 volts. Constant current mode kicked in, and it was drawing about 3 amps. I said, well, this ain't good. Sounds like the motor's stuck. So all this was already out of the tube that it goes in. So I took the motor apart, and what I found was the armature in here. I was thinking it was going to be in the gearing, but the armature was rusted to the case. So penetrating oil, little tapping, finally broke it free. Put the armature in the lathe, sand it down with some emery cloth, clean the magnets inside, put it back together, and the motor now works. So I put the antenna together, and when I switched the motor on, I could hear the motor running, but nothing was happening. It wasn't doing anything. I commenced tearing it all back apart again. So to give you a demonstration how this works, you can see this tube, the top of the mass mounting tube. We have this big coil, and this coil sits in here and actually moves up and down, and that's how it tunes the antenna. And here at the top, you've got this band that goes around that has finger stock on it, and that actually mates with the coil, and you can see these set screws around, mates with this part of the bare aluminum up here, and the motor just drives this thing up and down. That's all it does. Now this piece is not supposed to look like this. It actually, let me take this back off. This piece goes in here, and this goes into the bottom of this coil, and you see there's 3 bolt holes around that it bolts in. Here's the issue. This rod is stainless steel. This is aluminum, and you can hear that. This is actually supposed to screw on this. This is what makes it go up and down. As it turns, it screws this up and down. Well, the center of that piece of aluminum is stripped completely out, and if you look good enough, you can see some threads here that come off the aluminum piece. Well, I said, okay, no problem. They have already taken the 3 bolts out. They were missing to start with, so I said, I'll just pour this out. Well, that didn't work, because they had this piece glued in to the bottom of that coil. So imagine, if you will, this is on there, and you can see this insulator looks good. Well, actually it's not an insulator, it's a cushion stop, so that when this here gets to the bottom and the motor hits it, it kind of slows it down without stopping. And the same thing at the other end, where you see that one is melted, and the reason for that, I actually had this end in my vise. I had this propped up with a big piece of wood, and I had to heat the inside of this piece of aluminum, and then take a block of wood and put up against here and tap this thing off. Once I got the glue hot, it was easy to tap off. But yeah, they had it glued in place, so not only bolted, it was glued, so that caused a little bit of a problem. So hence why this insulator this rubber stop got melted, because that was actually pulling on it as I was heating and tapping the coil off, so that melted that rubber stop. So I'm gonna have to make another one to go on here. As you can see, this is stainless steel, that's aluminum. Which one do you think is going to give first? That'll be the aluminum. So making this out of aluminum wasn't the best choice, but I can understand they doing that to keep the weight down. But aluminum and stainless steel, it wears a lot differently. Now I could take this hunk of aluminum I got, cut me a piece out of it, mill it, drill it, tap it, drill the 3 holes back in the side, and be right back in the ballpark. But over time, the same thing is going to happen to this. It's that stainless steel is going to get the best of that aluminum. So you know, this being stainless steel would probably been a lot better, but you know, that cost the price of the antenna, you know, makes the antenna go up more. And steel is a bit heavy, and plus it'll rust. Moisture does get in this thing, so that wouldn't be the best idea. So what I'm thinking about doing is just cleaning this up, boring this out, and make a threaded insert to go back in it out of brass. I think the brass will last a lot longer than aluminum will. So that is the game plan. Alright, I got this trucked up in the lathe, and we're going to just go ahead and use the mini lathe instead of the big lathe, so that fits in there with no problem. And I'm going to go ahead and start boring this out. I'm going to start with something small. That way we just get those threads right on out of the way, what little bit's left in it. Okay, I had to switch memory cards. Okay, I forgot to change out the memory card, so lost the footage of drilling that out, and that's about 3/4 of an inch. What we're going to do now is bore the rest of it out. I'm going to totally get rid of that little flange there. Alright, there you go. Okay, so this hole diameter is not critical. What I'm going to do, I'm going to mill a piece out of this, and there'll be a flange on the back side of it. So this will slide in and then put 3 screws into the back side to hold the piece of stock in place, and then we'll drill and tap that. Okay, I have a little brass slug made. It's a pretty tight fit in there. I'm just going to come here and put 3 screws in here, and that will secure that to the mount, and then we can put this back in the lathe, drill it, and tap it. Okay, since my stock wasn't quite big enough, what I've done, I put an alignment pin in here, and that captures this thing, keeps it from rotating. And then I put 4 3mm holes around it, and we're going to put screws in there with washers to help capture this plane and hold it in place. Okay, got the new nut in. There's a pin in there to keep it from rotating, and it's captured by this plated washer with 4 screws. So that's not going to go nowhere. All I got to do is put this in the lathe now and go ahead and drill it and tap it for, I think it's 5/16 24. Alright guys, the new nut is all together. See, screws right on. No slop in the threads. Feels real good. So what I got to do now is make a new end stop to put on here, and then I can put the washer and bucket washer on, or flat washer. Yeah, that's pretty good there. Alright, so I got a rubber washer on here. That should be efficient to stuff it. So all I got to do now is get this back in here with all the holes lined up. There we go. Now I got to find some countersinking screws to put in here, because the ones that were supposed to be with it are missing. Alright guys, now for the fun part. We can put this thing back together. Take note that there is a magnet mounted to this hex nut with 2 tie wraps. Make sure that is straight and not hitting the mounting screws. And here we have a little screw that's mounts this to the main tuning shaft. I just need to loosen this up and I tighten it so it wouldn't fall out. And that's just captured with a small lock nut. Then we'll put our lock nut on and tighten that down. So you can see each one of these couplers has 4 holes in it. And what I like to do is take a Sharpie and mark these holes so that when you slide this down the tube, you can see these marks and then know you need to turn it to align it. It makes it a lot easier to line up those holes because you can't see inside of it. I'm going to connect a longer wire to this so that we can pour this through the tube. And on the end of the wire, I'm just going to drop a small winch. Drop a small wrench to give it some weight so it'll slide down in the tube. Make sure that your mount is free of any metal dust. We're going to drop this right down into the tube here. Well, I got the tube steadied in the vise. You can lift this coil up and start feeding this right into it. Now these 2 couplers are going to go into the small end down there. Let me take up my slack. So what we're going to do, we're going to push the coil in until we can see the couplers through these screw holes. And as you can see, I think you can see that one, a little white dot in there. So we know that one needs to go on down to this screw location. And we'll keep an eye on it. There it is. And there's our black mark. So what I need to do is rotate that until we see a screw hole. Now I got to go out and get some stainless steel screws to put into this, because I do not have any. So I'm going to just use some random screws that'll fit. Now I need to get the top coupler lined up, and there it is. Alright, so now we can put our top support on. You see this has finger strips in it that makes contact with the coil. It's a pretty tight fit on here. So I'm going to just take a small piece of wood and a hammer and lightly tap it till we get it all the way on. There we go. And we'll snug up these set screws. I'm missing 2 set screws. I got to get some more of those. Now we can take our top cover. I need to clean it out also. Alright, now we slide our cover on. And we put our top nut in. And with that on, we'll bring our ring up. Now, right here is a little 1/8 strip keyway, and that lines up with a little groove that's in this ring. What that does is keep this from spinning. Now we put our screws into this. Well, if everything worked out well, we should see this part of the coil move up. I'm just going to connect it to this little battery. This is going down. and hit the stop. Well, there we go. Our mobile antenna is now fixed. Okay, so now I got to do the search around and find a whip to go on top of this thing. Probably about 5 foot whip. You can buy them online. I probably got some around here. If you want to run 160, you put a 8 foot whip out the top of it. But for standard 10 through 80, 6 meters, 5 foot whip will work just fine. I got to get some screws to replace all the missing screws and the right screws to go in the mount. Now what you do have to remember is this whole thing, when you mount it, this whole antenna from the bottom of the pole to the top is hot. So this has to be mounted so that this is insulated and your coax hooks directly to the bottom of it. Now there should be a aluminum slug that goes in the bottom of this, and it's not missing, so I'll probably make that, and I'll fix it so that the coax can connect to it. And then you got to have a matching cord that'll come from the center of the coax down the ground, and that needs to be real close. So the actual mounting bracket will have an L-shaped bend on each end, and the top will be cut out so it'll slide down in with an insulator, and then it'll mount on the bottom with an insulated spacer. Something like you would use on a whip antenna to mount to toolbox of a truck, that little L bracket, that insulated spacer that comes in it with the SO239 on the bottom, that'll work good. And then you mount that core from that straight into the ground as close as possible. Alright guys, I went ahead and made an insert to slip in the bottom and have a opening on the side so the wire can pass through. And just remove these screws. And right now there's a 1/4-20 hole in the center that'll later be drilled out to set the stud that's going to go in there for the mount, which I don't have yet. I'll have to order that. So the other 4 holes here I'm going to just block off. Actually this right here should be on the other side. It should have been pushed up further so only this sticks out. But it's okay for right now. Okay, now I got it properly done. And got the little insert in. And that should complete that. Okay, so I got to get some more material together. So basically what we got to build now is a bracket that looks like this. You know, if you look at the top of it, there'll be a hole in the center, and this will be fixed here so that a bolt goes through it. In other words, it'll be split in half, and there'll be a rubber gasket in here that will insulate that pole from it. So the pole for the antenna is going to sit down in there. There'll be a coupling screwed in the bottom of it Then there'll be a hole drilled here with an insulator, your SO239, and then the rest of it will go through, screw into that. Then there's a coil that actually will come off of this. And this is the matching coil, and it'll go directly to ground. So that's basically all that's going to be. This is probably going to need to be some 1/4 inch aluminum, about 4 inches wide, however tall it needs to be to get good stability. And then your mount will be on the back of this here, whatever it mounts to your bumper or whatever, and this will attach to that and hold this thing steady. So the type of insulator you use, like I was saying before, so the type of insulator you use, like I said before, it's basically just like this fitting right here. So there's an SO239, goes through, it's grounds on this bracket as an insulator, and then it's got this coupling that screws on top of it, and then your antenna will sit here and screw into that. So guys, again, that was all Tarheel. It's the M200HP antenna, just about ready to go. Like I said, I looked on the internet. Very little information on repairing these antennas, taking them apart. And so I saw one guy, he did the Tarheel 2. Yeah, the Tarheel 2, which is a lot smaller antenna. I think much bigger around than the mast on this one. So I'll get the rest of the stuff together, and we'll do some testing on this thing. I might even mount it and use it as a fixed antenna, just to do some testing with it. So guys, as you can see, I went ahead and made a mount. This is 5/16 aluminum, and 1/4 inch back plate and 5/16 on the bottom. And this was part of an old door control like you would see in the supermarket, an aluminum frame that opened and closed the doors. And I cut this down and used the aluminum out of it to make this mount. And the bottom of the antenna is insulated by the coax mount. And as soon as I get a piece of material like I want, either some Teflon or Darran or something, I'm going to make a puck that'll go in here. But for the time being, I have a radiator hose cut in between the aluminum and the mast. So you can see the antenna is mounted right to that fence post. That's the top of it. That's a 5-foot whip. And down here on the bottom, I'll have our matching coil mounted. That mounts to the center post here into ground, and that gives it our impedance that we need. Now it's real bright out here today, so I'll try to get some measurements and see. So to aid in the video, as you can see, I went ahead and I put some tape marks on the antenna and went ahead and did some preliminary measurements. And this will help us a whole lot better to go ahead and just test this thing out and see how it does. So what I'll do is, I've got the up-down button connected to a battery, and I have our rig export to analyze the antenna. I'm going to go ahead and run the antenna down to the 20-meter mark. Alright, so we'll come here and we'll hit frequency, and we want them about 14,250. We hit OK, and we're going to scan the SWR. See, we're only off by just a little bit. Antenna needs to go down just a bit. Alright, go ahead and scan again. Went just a little bit too far, as you can see, but we are down to about a 1.2. Let's do it one more time. Yeah, we're real close on it now. Yeah, we ain't far off. You see just how touchy this thing is as far as getting it right. So SWR looks good on 20 meters. So we're going to go ahead and we're going to select frequency. We're going to put in 07200. Enter. I'll run the antenna up. Should be somewhere there. We'll hit OK. Standing wave's about a 2.5 on that frequency. Let's go up to 07250. Scan it there. It's about a 2.1, 2.2, somewhere in that neighborhood. Alright, we're going to put a frequency of 0385. And we're going to scan there. And you see we got a real high SWR on 38 or 80 meters. Let's drop it down to well, I might not have that frequency in right. 0385. Enter. Scan. Nope, not quite going to get there on 80 meters, but also we're connected to a galvanized coated fence. It's old and rusty, so we're not getting a lot of ground. I put this ladder back here and I tied a ground wire to it, so we're mostly just grounding on that ladder, which is not going to be enough. So let's try 15 meters. 21.3. Yeah, about a 1.2. So the antenna needs to go up just a little bit. Let it rescan. Yeah, that went down to a 1. So it looks like we're going to be all right on 15 meters also. Alright guys, I went ahead and replaced the analyzer with a radio. It's 2 and 20 meters. Let's see what we hear.
New York.
GSL 590.
Thank you. Kilowatt 2, America.
Number 0, Bravo Sierra.
209 November, Kilo India, 59 New York. Thank you. Kilo 2, America.
Number 0, Bravo Sierra.
Kilo 4 is a Whiskey Alpha Whiskey. Kilo Mike 4, Bravo, Lima Hotel, 59 New York.
We're going to try some 40 meters.
K2.
G as far as Georgia, you definitely need some equipment, man, because you can't even hear him. Well, we just need to get on 40 or at least 80 at night,
Yeah, roger that. I mean, it just makes it interesting. I've tried that desert to load, and it's just not for me, fellas. I've tried.
Well, guys, I think the antenna's going to work just fine. Like I say, we don't have a lot of ground here. Like I say, this old chain link fence is old. It's probably been up 25 years. It's rusty. It's galvanized, coated in a lot of places. Like I say, I did attach the ladder to the fence and then ran a wire to mount over to the ladder just to help give it some more ground, but it just isn't enough. I think if I put this thing on the pole where the mount is just at the eave of the house, and then connect me a ground strap from that to that big 2,260 square feet of metal roof, that thing will work pretty decent. Haven't tried it on 160. I do have a 102-inch whip I could put on it, and it would probably get 160, but I haven't tried it yet, so I might experiment that one a little later. Anyway, guys, that's the end of the screwdriver antenna saga. I think it's going to work just fine. Seems to do pretty good, and at least it's receiving well. We'll see how it goes when I go hooking a rig up to it and transmit on it. Anyway, guys, I hope you enjoyed it, and we'll catch you in the next video. Bye now.